for joining us today. This is John Morris. I'm the Chief Operating Officer for Time Compression Strategies Corporation, located in Indianapolis, Indiana. Today, we're going to go through a webinar with you to talk to you a little bit about the benefits, features, and functions of the Ancelus database. And we're going to show you a demonstration of the product, take you into the product live. And at the end of our discussion, you'll have an opportunity to see and try some of the product firsthand. Just a few details of what we're going to cover. We're going to cover the company history. TCS has been around for some 30 years and has a history of a number of products. We're going to share with you the growth and migration of the platform. We'll just share with you some of the key features and benefits of the database. And then David Layden, who's one of the owners, founders, and patent holders, is going to actually take you into the product and show you how to use it, show you how it works. He's going to talk a little bit about something you may or may not have heard of called threaded query language. And once David kind of goes through that, we'll give you an opportunity at a free trial and to take you into the self-directed training module as well. In the meantime, if you have any questions or thoughts or use cases when we're done, please feel free to email us and we'll be happy to get back to you and tell you how we can deploy Ancelus in your environment. So a little bit about TCS. TCS had some of its first real-time systems introduced in 1983. And this is the early versions of the database that we'll be sharing with you today. But a few specifics about our history and genealogy of the technology. This is the third generation of the Ancelus database. We have the first generation of the product that was created in 1986. It was the first in-memory database. In 1986 and 1993, we completed the first patent for in-memory columnar and graph databases. A lot of people think graph databases are something new here at 2020. It is not. We were one of the first in 1993. And then in 2013, we had the first patent on a hybrid algorithmic database. And so the work that we've done up until now is a culmination of some 30 years of work. Our products have been installed on 30,000 different systems around the world, and we have 1,200 past and current customers. Well, you'll hear more about this momentarily, but some of the key features and benefits of Ancelus are its speed. Ancelus is 10 million times faster than the fastest relational databases you're probably familiar with. We have 100 nanosecond latency, if you will, on a single transaction that's independent of size. And our database, because of some of the tools and the way that it's built, you can host Ancelus on a single server with thousands of users. Some of the typical tools and some of the processes that you would normally use in today's databases, you don't do in Ancelus today. We take a lot of the database tools and activities out of the database, and we'll share that with you momentarily. We use Ancelus compression, and you can reduce the number of servers that you need in your hardware expense by about as much as 70% because of the compression, and we'll share that with you here momentarily. And then lastly, there's 15 different development tasks that you do not do in Ancelus. And so those of you who are database administrators that build and manage databases every day, I'm sure you'll be glad to understand what those are. Everyone's looking to reduce the amount of work that they have to contend with. And lastly is the operational efficiency. You do not take the Ancelus database down for maintenance or schema changes. You can make those changes on the fly, and we'll share with you how that's done. And so we'll be moving along with David showing you how threaded query language works. One of the things that's also important to understand about the Ancelus database is its ability to scale. You know, that's a limitation in terms of some of the other databases that are out there. It doesn't matter whether they're NoSQL or SQL databases. It's difficult for them to scale. We can have a single image up to 16 hexabytes, which means a number of different things in terms of size of the database and the information that you're managing, but not the least of which is it doesn't require as much hardware or as many servers to use an Ancelus database as it would be with a typical NoSQL or SQL database. and it eliminates most, if not all, of the scalability failures, and we'll share with you details about that here shortly. David Layton, who is our CTO and owner and one of the patent holders of time compression strategies, we're the firm that makes the Ancelus database. David is going to take you in and actually show you the product and how it works. Before we do that, we'll talk a little bit about the development speed. Not only is the database itself very, very fast, very, very scalable, but there are some tasks that you don't have to do in an Ancelus database. You can simply skip them with Ancelus, and you can't skip them with others. This is a brief list of the 15 tasks that you do not do as a DBA in the Ancelus database. And we can share a few of these in detail. If you have some other questions about some of these things that you do not do in our database, please let us know. So now David Layton is going to start with the demo. If you have any questions or comments, please let us know, and we'd be glad to get back and respond to you. So now is Mr. Layton.
Now we'd like to provide a brief live product demo. We'll start by demonstrating ease of use. We'll use the Ancelus control panel. From here we can do the admin functions of the database in real time. For example, if we wanted to create a new database, we can create a database. Let's create a 10 gigabyte database. So here we have a 10 gigabyte database. If we look at resource usage, you'll discover that we have a 10 gigabyte database available now to use. We can also restore databases that are already saved to the disk. So if I go to restore database, I can choose a database of interest, restore that database. If we now go to resource usage, we have many tables now that we've just restored to the system. With this restored database, we can actually perform a threaded query, which is a query that accesses many different tables. For example, if I want to look at the part number for a unit, I have to actually go through the job table in order to get the part number. When I select the part number, it automatically selects the unit and the job, so on. Then I can ask for events. But the other thing I can actually do, I can actually restore a query that I've saved. Here's a unit history query. If I restore that, so now we have the unit selected, the job selected, the part selected. We have events for the unit. We have name value pairs associated with the events. So here's a complex query that we can actually go perform. And I would like to do a unit history for a particular unit. For this particular unit, I would like to do a unit history. If I click on that, it's done. I can review the results. Now, the result is not a flat file. The result is a hierarchy. So you're going to get unit records. We've tagged those with a U. We're going to get event records. The event record will have the unit quantity, the process, the user, the location associated with the event. And within the event record, we'll get tag value pairs for our tracking system. So here's my unit of interest. There's the job, there's the part number. Within that, I have an event, and that event has a process, it has a user, it has a location, and within that event record, there is a tag value pair. Here's an event that comes later, and it has 2 tag value pairs associated with it, so on and so forth. So there is a complete history of that unit, and it spans 7 different tables. So now, if I like, I can drop that database. So let's do an example. Let's create a very simple example database. So I want to create a database 100 meg is big enough. So now I have a 100 megabyte database. So I can actually populate this database with tables. And I'm going to start by putting into this database a table called part number. Its characters, it's going to be 40 characters worldwide. And I think I'd like to have 1,000 part numbers in my database. So now I have a database and I have the first elements of a table. So go look at resource usage. Resource usage. There is a table called part number. I have a 100 megabyte database. Now, rather than actually doing this piecemeal, there's actually a better way to do this. So I'm actually going to drop this database. And I would like to recreate that database, but I want to recreate it and I want to load it with real random data. So how do I do that? Let's go to our command prompt and let's look at a file here. This is a schema file. It's the same thing that we did. We're going to create a part number table, 1,000. We're going to create a serial number table, 1.1E6. That means 1.1 million. Then we're going to add a foreign key into the serial number table, which references part number. Then we're going to add a key list associated with part number that represents all of the serial numbers for the part number. And here is a very tricky part we're going to do. We're going to automatically load the key list field based on the foreign keys that are entered into the serial number table. I'll explain a little bit more about that later. But we can actually build this database now, and I would actually like to time the building of this database. So I would like to do how long will it take us to build that database? 1,000 parts, 1 million serial numbers. That took 14 milliseconds. They're empty. These fields are empty. So there's a room for 1,000 parts, there's room for 1.1 million serial numbers, but there are none in the database at this time. Now, what I want to do is I want to take a spreadsheet file. I have a spreadsheet file on my system called pn.comma separated variable. The first record in that file says this is the column I want to load, part number. And here are random part numbers, 1,000 of them. I want to load those random part numbers into my part number table, and I want to time it. Part number dot comma separated variable. So how long does it take to load those 1,000 part numbers into my database? 3 milliseconds. Now, I would like to load the serial number table. Comma separated variable. But the serial number table is going to have random serial numbers, but associated with every serial number, there's going to be a part number. This is a foreign key in the serial number table. Now, the foreign key appears to have 40 characters in it, but it does not in the database. Foreign keys in Ancelus are not data, they are references to data. So in fact, when I load this 40 character part number into the database, it's only going to take 4 bytes of actual data space. We get a 10-to-1 compression ratio by loading references to data rather than data. As I'm loading the part number foreign key into the database, I'm also going to be building the linked list that associates part numbers to serial numbers at the same time. That's going to be automatically, there's a stored procedure which automatically updates that linked list associating part numbers to serial numbers. So there's a great advantage there. Now, first of all, let's time this. I want to time loading the serial number table. This is going to take considerably longer because I'm loading 1,000,000 serial numbers into the database, and I'm also updating the foreign key and the key list information at the same time. This is going to take much longer. In fact, this is going to take 1.6 seconds to load that information into the database. So now we have 1,000 part numbers and 1,000,000 serial numbers in the database. If I actually look at the serial number table, so if I look at the serial number table, I see a serial number and a part number. The part number is a reference to the part number. It's only 4 bytes here again. And if I go look, and I can see all of the serial numbers in the system. Now I have a little benchmark routine that actually prints out the list of serial numbers for a part number. And it looks like this. It produces a part number, and then here are all the serial numbers associated with the part number. It's a list of part numbers or serial numbers associated with the part number. Here, and if I can actually find the next part number if I want to. Here's my next part number and all the serial numbers associated with that part number. If I run that and actually don't print it out, but if I just want to time how long it takes to get all of the serial numbers for all part numbers. So I want to get all 1,000,000 serial numbers associated with all the 1,000 part numbers. I can actually time that. So if I run that, that took 129 milliseconds to get all the 1,000,000 serial numbers for all part numbers. So that actually is running 7.7 million transactions per second. Here's the interesting thing, though. That's not the end of the story. What happens if I run 16 in parallel? Because it turns out this particular piece of hardware has 16 processing threads available. What kind of performance will I have in aggregate if I run this utility? And I want to do this completely randomized, so I want all 16 utilities to be sampling a different set of part numbers. But for each part number, I want to get all the 2,000 serial numbers for each part number. But I want to run these in parallel. I have a very nice utility to do that. I want to run 16 versions of it, and I want to run them in the background in parallel. So what happens when I do that? I don't get 7 million transactions per second. I get 5.7 million transactions per second, but I do that on 16 different processing threads. So in fact, I extract 160 million transactions from this database in 1.756 seconds. And that transaction rate is 93 million transactions per second. Check my math, but I think if you want to list transactions per minute, that would be 5.4 billion transactions per minute. Now, it turns out I'm running this benchmark on an old desktop computer that's cost $1,000. Not recommending that you run your enterprise on a $1,000 computer, but the point is there's enough performance headroom in this product that you can run your enterprise on a relatively inexpensive server class machine and get better performance than we've demonstrated here. You don't have to pay $1 million for a system. You can do it on a relatively inexpensive piece of hardware and get incredible performance out of the system, and it scales up on multi-processor systems. That's the example. We call it a nanosecond database because the time for the transactions are in nanoseconds. Thank you for listening.
We Thanks, David, for the demonstration. Um, the Ancelus and the database, there's a lot of feature function that we didn't have a chance to share with you just given the last 20 minutes or so as David Layton was going through the functionality of Ancelus. What you can do, however, is if you want to learn more and you want to be able to deploy the database, and you've got some requirements around speed, complexity, and size that your current database tools are not able to address, we invite you to sign up for a free trial of the Ancelus database and the self-directed training module that's a part of that. And you can go in and see how the database works and see how you can customize Ancelus to be able to be deployed in your environment. All we need is your email address to register. And if you go to training.ancelus.com/request access, I'll get an email from that link requesting access for you to our training system. We can get you registered and you can go through the self-directed training and see how Ancelus can work in your environment. In addition to that, if you have any questions or comments, you can go to the Ancelus.com website, send us an email, or you can call me, and I will be glad to answer any questions and get back to you as quickly as I can. But thank you again for listening to us today. We look forward to coming to you again with a series of webinars in the coming months. Thank you and have a wonderful day.